lost track of time. She's on her way.
Okay, great. All right, well, welcome everyone. Welcome back to episode 3 of Body Systems Summit. I'm so glad you could join us tonight. And tonight we are going to be talking about the immune system. So we're going to get into some kind of sciencey stuff, but I will break it down as best as I can for you. I think that the way that it's presented is a lot more understandable than you might think. It is a big topic with a lot of different sort of aspects to it, but we will get through it like we always do. And as always, I'll take questions at the end. You're also welcome to type them in the chat throughout the presentation, and I will address them as I can, or again at the end. So without further ado, let's get to it. Okay, so again, this is episode 3, which is immunity. So the immune system is one of the most complex and arguably the most efficient system in our bodies. So you can kind of think of it like a football team. There are multiple players doing different things at the same time, but while that might seem chaotic, they have a very cohesive and organized system that keeps you winning at life. So the field that they play on, obviously, is your body. So the immune system is comprised of various types of cells that are distributed throughout the body, and these are basically your body's security system. So the security system is constantly running surveillance to look for pathogens, invaders, cell damage. So this can include anything like a virus, any kind of bacteria, and then also any cells that might be mutated or damaged. So an example of this would be cancer cells. They are normal cells that have either grown out of control or turned into basically a mutant. So they look for that, and then they also look for any type of toxins. So all of the cells of the immune system communicate with other cells outside of that system to relay information about what it's doing or what it needs. So the immune system can kind of communicate, hey, here's what's going on, so nobody panic, we've got it under control, or maybe they need some backup from another system and they'll relay those signals as well. One example of this is it talks to the endocrine and to the nervous systems to help maintain homeostasis or balance inside the body. So the main key points that you need to know is that the purpose of the immune system is to have this network of cells, organs, tissues that all work together to protect the body against invaders. Inflammation is a response of the immune system. So this is really important to know because inflammation on a certain level is a good thing. It's a necessary thing. Okay, and it's a response that consists of these 4 different reactions. You start with heat. Okay, so this would be like a fever, for example. This is why you get a fever when you are sick. The immune system is raising the body temperature in an attempt to kill whatever the organism is. Then you may develop redness. Okay, so think of an injury. It starts to turn kind of red, then it swells, and then finally pain. So these are the 4 sort of steps in the inflammation process. Again, remembering that it is meant to be a short response in reaction to one of those things that we've talked about, and is not meant to be a chronic process. Okay, so inflammation kind of does its thing, the immune system goes to work, and then when the job is done, the inflammation is supposed to subside. So the 3 primary functions of the immune system is to identify foreign invaders and then generate that communication system. Here's what we're doing, here's what we need, and kind of like mobilizing the forces. And then they launch their attack. All right, there are 3 layers to the immune system, which I will break down for you, but the first is the physical barrier. This is also innate immunity and then adaptive immunity. So it's important to know the difference between those. I'll talk about that here in just a second. And the immune system is very resilient and adaptable. So it's able to respond to a variety of circumstances and also external influences. So it's got to basically be ready for anything at any given time. And this, of course, is assuming it's working properly. So all of these 5 key points and functions are assuming that the immune system has proper function. So these are just some terms because, like I said, it's going to get a little bit sciencey. So you may want to refer back to this slide as we go through, but these are kind of some basic terms that you're going to hear repeated throughout this presentation. Number one is pathogen, which is any disease-causing organism. And then you have an antigen. So an antigen is a molecule that stimulates an immune response. So this is something that's introduced into the body. And then the antibody is the response to the antigen. So it's a protein that's very specialized to kind of tag the antigen for destruction. So it identifies the antigen, it puts a little tag on it, and then the appropriate other parts of the immune system will take care of it. Okay. So the innate immunity is your non-specific immune system. So this is kind of your immune system as a whole. And then adaptive immunity is a very specific. And again, this will get a little bit more broken down for you. The B cell is what makes antibodies. So pretty much all of the cells, with the exception of, most of the cells in your immune system are white blood cells, okay? So the one that produces antibodies is the B cell. And then the T cell is a specialized cell that will either help out the B cells. So if you see them called helpers, that's what they're doing, they're helping, or they will directly destroy infected cells, and these are called killer T cells. So again, basically the chain of command here is that the antibody will identify and tag that antigen, and then the T cell will come in and destroy it. Okay, so it's a very organized system. A lymphocyte is a white blood cell that's produced by the lymphatic system. So the lymphatic system is one that we have not covered yet, but we will. And it is it's kind of a circulatory system, except it circulates lymph and not blood. All right, and it has a very strong role in immunity. And then you have cell-mediated immunity, and this is an adaptive immune response. So this is the process of those killer T cells destroying those foreign or damaged or infected cells, all right? And then finally, you have cytokines, which are a type of proteins that are released during inflammation, okay? So that is their main function, is to get activated during the inflammatory response. So here's some cute little pictures of your white blood cells. These are what your little guys look like. So you'll see that there are granulocytes and agranulocytes. And as demonstrated, the granulocytes have these little granules that float around inside them. So these are your neutrophils, your eosinophils, and your basophils. And then the ones that don't have the granules would be a lymphocyte and a monocyte. I know this is real science, you don't freak out. I just want you to see kind of how they are made. So they basically, to make a long story short, they all kind of start off as the same type of cell, and then they will be coded by our DNA, our body's DNA, to become a different type of cell. So depending on what we're looking for, or what we need it to do, the body will differentiate them into these different types of cells. So you don't really need to know this too much, again, other than knowing that a lymphocyte can become kind of any of these other things, and it can be parceled out to have different functions or to different parts of the immune system or different parts of the body. Another kind of busy little one, but this is a basic diagram of how the immune response works. All right, so we start with our antigen. So remember, this is our little invader, okay, our little foreign protein or whatever it might be. All right, and in an allergic response, you have your B cell, which communicates with this plasma cell. And then this releases what's called IgE, which is another type of immune protein. So IgE is the protein that's activated when you have an allergic reaction. So if you've ever had allergy testing performed, that's what they're testing, is IgE. So they are looking for the release of IgE in response to whatever the food is that you've been eating, or it could be an environmental pollen, thing like pollen. And then you have these mast cells, which become activated, and they release histamine. So when you release histamine, this is when you might have a rash, you might have a runny nose, you might start sneezing, you might be itching. Okay, all of these are the result of histamine. And then here, this is the allergic response. Okay, the eosinophil also plays a role in that as well. But the main thing is this mast cell that activates that histamine response. So when you're taking something like Benadryl or Claritin, these are antihistamines. So they are helping to blunt this response of this histamine, which results in that reaction. Okay, so that's why it helps to get rid of hives or whatever response you might be having. And then down here, this is kind of the same diagram I showed you before, which is where you have your different types of, these are the helper cells, different types of T cells. These are all proteins, interferons and tumor necrosis factor and all this kind of fun stuff, which is either your NK cells or your macrophages. And this is where your cell-mediated response occurs. So again, a little more complicated than you really have to know, but I just kind of wanted you guys to get something of a picture of what that actually looks like. Okay, so let's get into these kind of layers of the immune system. The first one is the physical immune barrier. As you might imagine, this is our body's first line of defense. So the first one, the biggest one, is our skin. So the skin protects the inside of our body from the outside world. It is our largest organ, obviously covers the entire body. And so you pretty much have to rely on your skin as defense number one. Number two is the digestive tract. As we talked about in the first episode of this series, the digestive tract protects the inside of our body from the GI tract contents. Remember, everything is supposed to stay inside of the GI tract and not leave to other areas. Okay, so again, we have the skin protecting our inside from the outside, and then we have our digestive tract protecting the inside from our very inside, right? Both our skin and digestive tract are surrounded by epithelium, which is basically a layer of barrier cells. So they are that barrier. So remember, if we think back to episode 1, where we were talking about that gut barrier or the intestinal barrier. So that's epithelium, okay? Same thing. So they are covered in these mucous membranes, and that's what creates the actual physical barrier. So if you have damage to these epithelium, you have decreased your first defensive line. So you've already kind of weakened the defenses. Damaged skin, for example, will become permeable. So more things from the environment are allowed to enter the body. Now, fortunately, we have multiple lines of defense. So anything that does get in has to contend with our innate immunity, and this is our second line of defense. So this is a primitive system of defense that all animals possess. Okay, so any animal that walks this earth has an innate immune system. We are born with it. It is programmed into our DNA, and also somewhat through the mother. So like when you are born, when you come through the birth canal, you acquire immunity from that. You acquire certain cells, certain bacteria, also through breast milk. Okay, so that is all passed on through the mother. But our immune system, innate immune system, knows what to do from day one without any prior exposure. Okay, so it's kind of like instinctive, right? Again, it's very primitive. It's very, very ancient system. So this consists of our NK or natural killer cells, our phagocytes, and our lymphatic system. So the star players in this are going to be the phagocytes, which are both macrophages and neutrophils. So the neutrophils are like the hunters. Okay, they chase down the invader. They're like, I see you, and they start running, they start chasing them, and they kind of pounce on them. And then the macrophage comes and basically like vacuums them up. And if you ever really want to geek out and look at a microscopic video of what's happening, you can literally see the macrophage. It's like Pac-Man, okay? They will go around and just and kind of like suck them up. It's really, really cool. So they kind of go and mop up the little guys. So neutrophils chase them down, macrophages eat them. And then also these phagocyte cells will activate cytokines. So again, these are those proteins that are released during inflammation. So this is what actually activates the inflammation or the inflammatory response. This is also known as a cytokine storm. So when you have a cytokine storm, this is when you're starting to feel maybe some pain, maybe some redness in the area. That's that cytokine storm, okay? And during the cytokine storm, those natural killer cells get to work and they start destroying any infected or damaged cells. These are produced by your bone marrow and your lymph nodes. All right, so they are produced inside the bone and in the lymph node, which are located all over the body as part of the lymphatic system. And then once all the invaders are neutralized, then we have resolution of the inflammation. So you can see where innate immunity occurs through different systems of the body. So we have the respiratory tract. We've got those little hairs in your nose. They have a purpose. That is part of your immune system. They're little filters. Mucus itself, the cilia, which are any tiny little hairs you have anywhere. So that's in your nose, in your ears, anything like that. And then you have little microbial molecules that also help. So these are part of this microbiome that we were talking about. So you don't just have them in your gut, you have them in your respiratory tract as well. And they also can serve as part of this defense system. You have them in your skin. Okay, so again, you have some bacteria and organisms on your skin. You have them in some of your enzymes in your RNA and your DNA, certain types of your epithelium, and then some fatty acids. You have them in your urogenital tract, so in your urethra and your ureters. This is a discussion that we'll get into a little more when we talk about the urinary system. But one mechanism that we use here is pH. So the urogenital tract has to maintain a very acidic pH so that you can kill those pathogens. Most pathogens cannot survive in a very acidic environment. So that pH is very important. So that's part of why if you've ever had a UTI, a urinary tract infection, a lot of that has to do with the pH of your urinary tract not being low enough to where it's not acidic enough and the bacteria are allowed to thrive. You also have some mucous membranes in there. You've got microbes in there and then fluid pressure. So essentially urinating regularly helps to flush pathogens out of that tract. So really important to stay hydrated. This is like reason number 1001 to drink your water, because you need that to produce mucus and you need that to create that fluid pressure so that you're able to flush it out. And then finally, we have the GI tract. Again, there's some pH issues here. Remember, we talked about the stomach needing to be a very acidic or very low pH in order to kill certain pathogens and certain bacteria. So that's what this is referring to. You've got mucus in there. You've got enzymes. You've got microbial molecules and commensal microbes, or those little probiotics. Okay, so again, you can see that immunity is happening all over the body. Okay, so adaptive immunity is also called acquired immunity, and this is a programmed immunity. All right, so remember, we're born with the innate one. That one is very general and kind of generic. This one is a little bit more specific. So this happens when you've already been exposed to something and your immune system like remembers it. It takes this little picture of this. Okay, so like the first time you ever have any type of virus, first time you ever got the flu, first time you ever got a cold, first time you got COVID, anything like that, the immune system will remember it. Okay, so it is able to recognize the past offender. So it already has built a strategy against it, because it's like, okay, well, this is what we did last time. Here's what worked, here's what didn't work. It's really amazing. So it uses these specific antibodies to that pathogen or that offender to mount this strategic response. Okay, so when you have a B cell, these are derived from stem cells. So a stem cell is basically a general cell. Like when a cell is born, it is a stem cell. Okay, they're found in the bone marrow. They're distributed by the lymphatic system. And the B cells have these antibodies bound to them called membrane-bound antibodies. That's what's designed to react to a specific antigen. So when the antigen is identified, these little antibodies bind to them and they turn on a signal for the cytokines or those inflammatory proteins to start to be released. Okay, so I don't know about you guys, I'm very visual and I tend to like think about things in my head. So I'm like envisioning this happening right now, and it's like they like jump on its back and they like hold on, and they fire a flare into the air, and then here comes the cytokines. I don't know, that's just my brain, but it helps, I think, to understand things that way, to kind of almost animate it in like a cartoon out of it. So if that helps, please feel free. Anyway, so then you have your T cells. All right, these are also forming in bone marrow, but they mature in your thymus, which is an organ in your throat, and these form receptors. So these receptors will rearrange so that they can bind to different things. Okay, so again, a B cell is very specific, and it will attach to a specific antigen. A T cell will change its form or its shape or its configuration to be a little more resilient, and it can adapt to different. But each shape or each form will only bind to a certain receptor, if that makes sense, because that will create the correct signal. So it's like a puzzle piece. So it might change the form, but that form is specific to a certain antigen, and that binding will signal a specific response. Okay. The different types of T cells, like your killer cells, your helper cells, you also have regulatory T cells. These help the body distinguish between the self, in other words, the cells in our body that belong there, that are correct and not damaged, and non-self. Okay, so this is really important to understand, because this is where autoimmune disease comes from. Because autoimmune disease, that ability is lost, the ability to distinguish between the self and the non-self. So any dysfunction of that T cell signaling path, of any of those signaling pathways, is when you start to see autoimmune diseases. Okay, so let's review the lymphatic system. So this is a series of organs and vessels. They contain a fluid called lymph. All right. The primary organs of the lymphatic system are the bone marrow and the thymus. So again, this is an organ in the throat. Secondary would be your lymph nodes. Okay, so if you're getting sick, or sometimes it can happen when you have an injury, but you'll feel the lymph nodes. It's usually like the ones in your throat, kind of right under your chin. We have them in our armpits. We have them in our groin. We've got them all over. There's these patches in the small intestine called Peyer's patches. So you might remember that I told you that most of the immune system cells or tissues are in our small intestine, and those are the Peyer's patches. We also have them in our spleen, our appendix, and our tonsils. So again, if you've ever been sick, like if you've had tonsillitis, for example, or you've had ear infections, your tonsils will swell, and that's because they're part of that lymphatic system and that immune response. The Peyer's patches in the small intestine produce up to 80% of our body's immune cells. This is called gut-associated lymphoid tissue, or GALT. Okay, so again, back to the gut. Most of the immune system is in our gut. So that's what I meant when I said if your gut is not healthy, your immune system isn't either, because it's 80% of your defense right there. All right. We also have associated lymphoid tissue in the mucous membranes and in our respiratory system. So the fluid called lymph helps to carry white blood cells to where they need to go. So they are mobilized from wherever, the bone marrow, the thymus, the Peyer's patches, wherever they are, and the fluid carries them where they need to go. So blood is for red blood cells and lymph is for white blood cells. That's a good way to kind of look at it. And lymph will also help eliminate waste products. And in our lymph nodes, we will store these lymphocytes, these white blood cells, for later use. Okay, so they're kind of there waiting for when they're needed. They also will help to filter out some damaged cells. So there's constantly this circulation process going on, and that's part of what they're doing sort of behind the scenes, is they're catching any damaged cells and kind of trying to get rid of them. And again, they're located all over the body. And that's why they swell when you're sick, because they're working hard to eliminate the offenders for you. Okay, so what happens when we have some dysfunction? So proper immune function, like any proper function of anything, requires balance. So we need a balance of our anti-inflammatory and our pro-inflammatory responses. This is crucial, all right? So there is some theory about how this imbalance can occur. again, these are different types of proteins, all right, within the adaptive immune system. So you have these 4 categories of these these proteins rather. So the Th1 will activate a T cell response. Th2 activates a B cell response. Th3 is the kind of the regulator, and it tells things when we're done. Okay, so like after the immune response is meant to be over, the T3 will tell the inflammatory response to chill. Like, okay, guys, we're done here. Everybody go home. Okay, and then the Th17 produces these memory cells, and so when these cytokines are overactive, again, when the inflammatory response is overactive, Th17 kind of like takes notes to be like, okay, well, that was a little dramatic, so next time we won't do that, you know, again, if this is working correctly. So they all rely on one another, and they need to be in a balanced state. So if the balance is off and one of these is overactive, this is when you start to see maybe hyperallergenic responses, when you're just sensitive to everything, or maybe an autoimmune process, depending on what's imbalanced. Okay, so again, this is a theory. This is not proven that this is you know, a fact, but it's pretty solid, and there's been a lot of research on a cellular level on how this actually works and what happens when these guys are out of balance. So over time, this dysfunction and imbalance of the anti and pro-inflammatory systems leads to development of disease. So these are some things that can damage the immune system. Number 1 being excessive stress. All right. Number 2 is excessive sugar intake. And generally, I mean added sugars when I'm saying that. I'm not talking about eating a lot of fruit, because that actually can have quite a bit of benefits. Trauma from anything, from surgery, from a car accident, really any physical injury. So even if you break your leg. Frequently eating foods that you are sensitive or allergic to, because not all allergic responses are life-threatening. Okay, so just because you're allergic to a food, that doesn't necessarily mean you're going to have that anaphylactic reaction where your throat closes up and you suffocate. Like, that doesn't always happen. Sometimes you just get itchy. Sometimes you just sneeze or something like that. Okay, but sometimes that's not enough to get people to stop doing it. So if you continue to do that, or if you eat a food that you know causes some kind of reaction, whether it's a digestive reaction or you know, anything of that nature, if you're constantly still eating those foods, you are launching that immune defense, because again, it's a reaction is occurring and it thinks that it's not supposed to be there. Excessive intake of alcohol will suppress the immune system. Inadequate intake of certain nutrients, which we'll get into a little bit later. Dysbiosis, right? Which, remember, is the imbalance of the microbiome. And then frequent exposure to infections or any type of infectious agent. So those can all potentially cause damage. All right, so I want to touch back on this acute versus chronic inflammation. Okay, so remember that inflammation is meant to be a short-term process and not a long-term process. The 3 goals here are to eliminate the cause of the injury or the insult, remove the cells, and initiate repair. All right, so it's eliminate, remove, and repair. It is controlled, it is self-limited. All right, so in an ideal immune state, this is what we're talking about. Now, if we end up in this long-term kind of chronic inflammatory state, this basically happens when the innate immune system, so again, this is the one you're born with, does not respond appropriately. So the cytokines, those inflammatory proteins, keep producing when they should be stopping. Okay, so the 3 P's of this are persistent, prolonged, and perpetuating. All right, so the signals aren't working properly. So the signal telling that inflammation, okay, time to stop. The inflammation is becoming uncontrolled because it doesn't know if it's not told. All it knows is what it's supposed to do, okay? So if that stop button isn't pressed, it's just gonna keep going. Typically with chronic inflammation, you don't see the signs of acute inflammation. So remember, we talked about the heat, the redness, the swelling. Those are not persistent, but often pain is persistent. So So this a lot of times can show up as joint pain, for example. Okay, so if you have joint pain on a regular basis, this is a good sign that there is some chronic inflammation happening to those joints. All right, this creates a state of oxidative stress. You're probably going to hear me say this term more than once, oxidative stress. So this is a loss of homeostasis or a loss of balance, and this results in suppression of the immune system. All right, there are various diseases that are associated with chronic inflammation. We kind of already talked about the autoimmune diseases, chronic pain, eczema, so a lot of like your chronic skin conditions, psoriasis too, Crohn's disease, which is an inflammatory bowel disease, allergies, cancer, cardiovascular disease, neurological disorders like Alzheimer's and Parkinson's. Remember these later. We will discuss these in the nervous system chapter, and obesity. So obesity in and of itself can create a chronic inflammatory state. So this is just a graphic to sort of tie in all of the different systems of the body that can be affected by this chronic inflammation, okay? So again, cancer, cardiovascular disease, we have eye diseases, we have autoimmune disease, we have lung disease, we have neurodegenerative diseases, which are nerve disorders, brain disorders, periodontitis, which is in the gums, metabolic syndrome, which we see accompanying obesity. It's a very specific set of circumstances within the obese state, and also age-related frailty. So even if it's not like a specific disease itself, part of why you see this decline in functioning and decline in movement and decline in thought in old age has to do with this chronic inflammation. And there's a lot of really cool research going on right now about brain inflammation and Alzheimer's and some of these other age-related brain degenerating disorders. So really interesting stuff. So some of the things that we think contribute toward this are accumulation of what are called senescent cells, which are basically old cells. Cells are programmed to die at a certain point, and if they don't die, they become dysfunctional. So that's what senescent cells are. Unresolved infections. So sometimes you could have a subtle underlying infection that you might not even be aware of, but it's enough to kick up your immune system, but you may not have symptoms. Dysbiosis, again. Overactive macrophages, which are those little vacuums, little anteaters. Dysregulation of those cytokines, those chemical signals, and those cell proteins that are involved in inflammation. Imbalance between the things that start inflammation and the things that stop, right? We talked about that already a little bit. Genetic mutations could certainly have to do with this if things are turned up too high or turned down too low. Epigenetic modifications, which basically is the concept that things in our environment can affect how our genes work. Okay, so every function in your body, every characteristic that you have. So whether we're talking about your toenails or your eye color, or if you can, if you're double jointed, like literally anything has to do with a genetic expression. So epigenetics can affect how a gene is expressed. So it can turn it up, it can turn it down, it can turn it off entirely. So that's what epigenetic means, is how the environment can affect genes. And then lifestyle factors like diet, exercise, etc. So again, like this should really be hitting home for you guys now, seeing how our body systems are connected and how all of them can be impacted by this chronic inflammation state. All right, so let's talk about allergies. So allergens are substances that cause allergy. So they can be present in the environment and the food that we eat. They are a type of antigen, all right? Again, antibodies, which are those little proteins that will fight the antigens. So immunoglobulins are the specific type of antibodies that fight allergens, okay? They are activated by B cells. So I kind of showed you this in an earlier diagram about that IgE. immunoglobulin E, which is what's responsible for an allergic reaction. So I'm not going to get too far into this rabbit hole, but basically just know that you have different immunoglobulins that are specific to that. But IgE is always an allergic reaction. The allergen exposure launches this massive antibody response. And as I showed you before, the mast cells will release that histamine, and that's your allergic reaction. Typically, allergic reactions are immediate, but they can be delayed sometimes. So they may not always happen right away. It can be in the case of what's called a pseudo allergy, or if it's a more subtle thing, it can actually come up later. Okay. And so one thing that histamine does is it increases the permeability of the capillaries. So the capillaries are your teeniest, tiniest little blood vessels. They're very, very small. So you can see them in your eyes, for example. They're really tiny. So when they become permeable, they leak. So fluid is allowed to escape out into the tissue. So this is why you get a runny nose or watery eyes, or you start sneezing. That's the fluid coming out of your capillaries. Then in more extreme cases, if there's contraction of the smooth muscle, that's where you get anaphylaxis or the closing and swelling of the throat. So at this point, when the allergic response is happening, the T cells come in and they start destroying that allergen. Okay, so histamines. I sort of touched on this already, but basically, when you are an extremely overreactive person, so if you feel like you react to everything, if everything makes your nose run or everything makes you itchy, this is largely responsible for this hyperactive response, is overproducing histamine. This is a problem I personally have, and I've struggled with for a long time, and I'm still working on it and still figuring it all out, but I get itchy from all kinds of foods. Here's a lovely list of things that Jean has problems with, but things like fermented and pickled foods, okay? Because they do contain bacteria, right? They're fermented, they're pickled, so they're living organisms in there, and they sometimes can create that response. Alcohol, particularly alcohol with sulfites, so like wine, in particular, tends to have sulfites. You can get sulfite-free wine. It does exist, but the sulfites in particular will kick it up. Food dyes, certain types of preservatives, and certain types of additives. One additive that can be problematic is citric acid. Okay, so citric acid, which does occur naturally in citrus fruits, but it's also used as a natural flavor, for example. So when you see that term natural flavor, that actually is a huge category of things. Synthetic citric acid is actually grown on the Aspergillus mold. So I never understood this until recently, but I found out that this is how they make citric acid. And I'm like, well, no wonder it sets me off, because I'm allergic to mold. So just these crazy things that you would never even think of. Refrigerated leftovers. So a lot of times there is an inability to tolerate things that have been sitting in the fridge for a couple of days, because even though it's safe for most people, you are already growing some kind of microorganisms on them, and that can be enough in some people to trigger that reaction. Certain types of bacteria. This could be bacteria inside your body or from outside. Genetic mutations. So there is one called MTHFR, which I also have. This is a mutation that affects your metabolism of folate and of vitamin B12. And part of the pathway of that has to do with histamine production. And then in some people, certain foods will cause histamines to kick up, which could be citrus, it can be strawberries, certain types of cheese, avocados, bananas, olives. I mean, there's a lot of them. Some people don't really react to these. Some people react to some of them. But sneezing, itching, congestion, hives, this will occur almost immediately. Like I literally can take one bite of something and I will start itching immediately. Like immediately. And it resolves quickly, but even still, it's an instantaneous reaction. And it's, by the way, that MTHFR mutation is extremely common in women. Now that we have been able to start testing our genetic profiles and seeing what our mutations are, it looks like it's about 40-45% of women have this mutation. So it is definitely worth finding out, especially if you have some of these things that I've been saying and you're like, oh my God, maybe I have that. It could at least give you some explanation for what's happening. And then you can target that, and you can use epigenetics to help regulate that gene. Okay. So definitely worth checking out to just kind of do some investigating. Okay, so then there's food sensitivities. So this is a little bit different. Okay, so again, a food allergy typically is an immediate and obvious reaction. Food sensitivities involve different antibodies. This is your IgG instead of your IgE. So again, the reaction is usually not immediate. Sometimes it can take days to show up. Most of the time it's going to be hours, maybe the next day. All right. Here are some common symptoms of food sensitivity. I talked about joint pain. Okay, so remember that pain is an inflammation signal. So if you're getting pain and you have no other obvious reason, like there's no reason your knee should hurt, okay, maybe it's something you're eating. Bloating and gas in the stomach. Migraines are a big one. Migraine is a big sign of histamine overproduction, by the way. Asthma, any kind of like congestion or sinus issues if you get like a lot of sinus infections, skin issues like rosacea and eczema. And then generally, if you kind of have low energy and just like don't really know why, you know, like you sleep pretty well, you feel like you eat pretty healthy, like there's no real reason, and you just feel kind of sluggish a lot, this could be this chronic IgG reaction. Generally, it's felt to be caused by leaky gut, which we talked about in episode 1, where some of those antigens from the food particles are leaking out into the bloodstream, and they're attacked by the immune system. Also, incomplete or impaired nutrient absorption can be doing this, because you need certain nutrients to help your immune system to respond properly. So if you're not getting those nutrients from food, then the immune system can be kind of wonky. There can be a serious impact on other organs and tissues. It is often overlooked in allergy testing, because in allergy testing, they don't do the IgG test unless you're specifically asking. So if you go to an allergist and get an allergy test, you're getting the IgE done. So it may say you're not allergic, but that doesn't mean you're not sensitive. Okay, so it's important to know the difference. It can be performed, and even this is not very accurate. It's actually pretty inaccurate. So like if you have seen ads for those food sensitivity tests, like I think there's one called Everlywell or something like that. There's a couple other ones. These are really not very good, because the IgG is very, has what's called low sensitivity. So the best way to really figure out your food sensitivities is with elimination and then reintroduction. So you take the thing out of your diet that you think you're reacting to, or if you don't know, you kind of do like this general elimination diet, and then you work with a dietitian or somebody who's educated in this to help reintroduce foods and see how you're reacting to them. So that's really the gold standard for figuring out food sensitivities. The IgG testing can be used to confirm those, but I would not use those as a sole indicator. So again, this is just kind of another diagram of an allergic reaction. You have your little antigen here. Here's your Th2 cell, which will activate that B cell. The B cell is attaching to the allergen, because remember, it makes these little bonds. Okay, and then the plasma, that will signal the plasma cell to release IgE, which is that antibody, and then they attach to these little mast cells. And the mast cell, like the B cell, it kind of passes the allergen. See how it kind of like goes from here to here. So it like passes it over and attaches it to the mast cell. And then this is where the histamine is released. And then again, you have your reaction. All right, so let's tackle the beast here, which is the autoimmune diseases. So again, these are induced by a chronic state of inflammation. And the white blood cells have lost the ability to distinguish self from non-self. So it starts to attack the body's own cells. We don't entirely know what causes this other than the chronic inflammation, but we don't know what starts that chronic inflammation. Like what changes the programming? What creates this kind of like breakdown in the system? Is it a weakened immune state? Is it a high toxic load? Is it adrenal compromise? Maybe it's all of these. We don't know. There's still a lot that we don't understand about autoimmune disease. But we do know, again, that there is some imbalance of those T cell proteins. The other issue with autoimmune disease is they often take years and years and years to develop. So by the time you have symptoms of something, it's well underway. And it can take a long time to diagnose. Medical diagnosis of autoimmune disease is very difficult. It's very much like a process of elimination. So again, the science is just not very good on this yet. Even with all of our modern medicine, we don't have a good diagnostic process in place. So they literally just start testing you for different proteins and different antibodies and different antigens to see what pops up. And then they just start eliminating. If you're negative for one thing, then they move on to the next. So they're very difficult to diagnose, unfortunately. And some of them can cause very significant loss in quality of life. So these are just some examples. Celiac disease is an example. Type 1 diabetes is an example. Multiple sclerosis, rheumatoid arthritis, fibromyalgia. I'm sure you've heard of at least one of these. Hashimoto's disease, which is an autoimmune thyroid disease. So there's lots of them. And again, just can be very difficult to, and a lot of them will have similar symptoms. So that's also not helpful. But we also are aware of things that can trigger their development. Stress, chronic stress, hormone imbalances, heavy metals. There's some evidence that chronic heavy metal load can impact this immune reaction. Food antigens, as I mentioned earlier, this constant exposure to foods that you might be allergic or sensitive to can produce this low-grade chronic inflammatory state. And then exposure to certain pesticides and poisons can also become, they can accumulate enough to where they cause damage to the immune cells. Okay, so cancer, unfortunately more common than we'd like. Cancer is crazy because it's literally our own body cells that have like lost control. Okay, so it's not like cancer is an invader per se. It's not a thing that you acquire. It's a thing that develops when your cells, something mutates and makes the cell go berserk. This could be the rate of growth. So how fast the cell is growing. This could be the type of cell that they change into. This could also be damage to the DNA where that error goes uncorrected. So that the DNA replicates the cell incorrectly. So usually it's more than one of these. It's some combination of things. Cancer can affect blood cells and non-blood cells. Many of them can affect the white blood cells. So leukemia, lymphoma. All right, these are cancers of the white blood cells themselves. So the cells stop maturing and they don't get to the functional level that they're supposed to be at, and then they just start multiplying. Others can affect the epithelium. So like skin cancer, stomach cancer, intestinal cancer, colon cancer. All right. So again, these are affecting that first line of defense that we have. And in inflammation, when you are constantly firing cytokines, those inflammatory proteins, this is a cancer-friendly environment. All right. So multiple things start happening here. Those genes that will program for cancer start turning up. So they like ramp up their expression. Cells mutate, tissues start remodeling, so the tissue mutates also. And that's when you start getting invasion to other organs. So you might have heard the term metastasis. That's what metastasis is when it moves from wherever it originated into another place. Tumors get blood supplies. Okay, so a tumor will actually start developing blood vessels. In order to feed itself, it needs to get blood supply. So it will actually do that. And then as a result of this, the cancer cells become stronger because they're spreading, they have more food, essentially, they have more blood supply, so they're better able to survive. So it really begins this kind of chain reaction. Okay, so we talked a little bit about this already, but stress is a big one. And the reason that stress is a problem is because when we have stress, like normally in a stress response, let's say you are in immediate danger, okay? We've all probably had a situation, or like somebody makes you really, really mad. We get this now too. You get this like flooding, you almost feel hot, and like your heart rate ramps up and you feel kind of, maybe you're a little sweaty. Like this is your stress hormone, this is cortisol. So normally this is supposed to prepare you for a fight or flight. Like you're either going to fight for your life or you're going to run away. Those are your two options, okay? But in more modern context, people that have high stress lives or are in a constant state of anxiety are constantly producing that stress hormone. So they're constantly in this fight or flight. And what happens is that this suppresses certain substances that reduce inflammation. So you end up in this chronic inflammatory state. Smoking, probably a no-brainer there. Certainly harms the immune system. High intake of sugars, fried foods, and alcohol, poor sleeping habits, chronic exposure to certain toxins, like we talked about the pesticides and the, certain poisons, chronic exposure to infectious agents or nutrition, nutrient deficiencies, and also certain drugs and antibiotics. So like if you're taking antibiotics chronically, you're constantly suppressing certain aspects of the immune system. You're constantly suppressing those healthy organisms that you have. And so that can kind of lead to some long-term issues. If, again, it's not going to happen if you need to take antibiotics for 5 days, if you have pneumonia or something, but if you're getting recurrent infections and you're constantly taking antibiotics, it's kind of a vicious cycle, because it means your immune system isn't good in the first place and it's just getting worse by this constant introduction. But the good news is there's lots of things you can do to help your immune system. Lots of immune supporting nutrients at play here. Vitamin D. Anybody who's worked with me as a patient, or probably had anything more than a casual conversation with me, I've probably brought up vitamin D. What's your vitamin D? Do you know your vitamin D levels? Because vitamin D is a critical nutrient with programming the immune system and its functioning. Zinc is a big one. So you've probably heard when you first get a cold, you're supposed to take zinc. So that's what like Zicam is. It will help activate the immune system, help shorten the immune response. Iron, folate, and B12, selenium, which is an antioxidant, omega-3 fats, and protein. You definitely need protein to make adequate white blood cells, for example. Antioxidants. So these are food substances. They aren't nutrients exactly, but they are found in food. They work to combat that oxidative stress and that inflammation. Some antioxidants can even directly target a pathogen. So vitamin C is an example of this. So another thing you've probably heard, you're supposed to increase your intake when you're sick, because vitamin C can actually directly target pathogens. Lots of herbs and spices. So these are things you can also ramp up. If you feel like you're getting sick, you can take echinacea. Echinacea has some pretty good clinical studies behind it as an antiviral and antibacterial. Rosemary, oregano, and some of these again are also directly antimicrobial. So they will target the pathogens and kill them. Oregano, rosemary, basil are all examples of that. And then gut bacteria. So they stimulate the production of that gut-associated lymphoid tissue, the GALT tissue in those Peyer's patches. And then they will also help protect that gut epithelium so that our first line of defense maintains its integrity. All right, so some I know this is probably all very like, oh my God, what do I even do? There's a lot you can do. Number one is eating a well-balanced and nutrient-dense diet. So really try to choose mostly whole foods, lots of color in your diet. I want lots of fruits and vegetables. I always tell people you need to be eating not just green vegetables, but you need orange and red and yellow and purple. You need all the colors. Okay. This will ensure that you're getting the biggest variety of vitamins, minerals, and antioxidants. Okay. Identify those foods that you're having sensitivities to and avoid them whenever possible. All right. So if you're looking to kind of start figuring that out, the ones I usually start with are gluten, dairy, and then maybe if you have a lot of those histamine reactions, if you have the itching and the runny nose and stuff like that when you eat, you may want to look at some of those high histamine foods. Okay, so being able to identify them is really the first step, and then you can avoid them, obviously, and then that will help to prevent this hyperactive kind of immune response. Vitamin D, we're back to vitamin D again. From sunlight, that's preferred, but some people, depending on their ethnicity, don't get vitamin D very well from sunlight. So for example, if you're very fair skinned, if you're from like a Scandinavian background, like Viking ancestry, you don't use vitamin D very well. If you're Black, you don't use vitamin D very well from the sun. So sometimes supplementation is needed. Also, people that live way up in the mountains, people that live at high altitude. So if you live like way up in the mountains of Colorado, the angle of the sunlight is not conducive to that conversion. So it's really interesting to see how different people, can be impacted. But the best way to know is to insist that you get your levels tested annually. It is not a standard part of annual lab work, but they will do it if you ask, but you have to ask. So I always tell everybody, get your levels checked once a year, figure out where you're at, and then supplement if you need to get it up. Exercise. Exercise has multiple benefits, not just to stimulate the immune system, but it also helps with circulating that lymph tissue. It also helps to keep the inflammatory response healthy. So exercise actually creates a state of acute inflammation. It's like I don't know what the analogy is I'm looking for, but it reminds the immune system what to do. It keeps it sharp, keeps it on its toes. Okay. So you actually want that quick acute inflammation that exercise produces. All right. Managing stress is a big one because we can't necessarily eliminate stress from our diet, from our lives, because it's everywhere. So we have to help our bodies adapt to it and to not be so physically affected, keep that cortisol level down. Okay, so exercise is a great way to do this as well. Exercise is not just in terms of that healthy inflammatory response and stimulation, but it also can help to, it'll help lower cortisol. It'll help with, again, circulating the lymph tissue, or the lymph fluid rather. And it produces endorphins, which are kind of like the opposite of cortisol. Okay, so it makes you release hormones that make you feel good, and they will sort of offset that cortisol release. Yoga, any type of meditation or spiritual practice, whatever your spiritual practice might be, meditation, prayer, whatever. And then there's things called adaptogens, which I am not going to get into too much, but adaptogens are basically herbs that help to suppress that cortisol response. I am actually drinking it's a non-alcoholic cocktail that contains adaptogenic herbs. So this is what I've been using in the evening instead of having a glass of wine, which, yeah, okay, I'll still have occasionally, but 9 times out of 10 now I'm having one of these adaptogenic beverages, which tastes really good and produces and has some of these nice adaptogenic herbs that help to kind of just calm you down and chill you out. And so it's sort of achieving the same thing that you're trying to get with alcohol, right? Except alcohol is just causing inflammation, whereas this is actually doing something beneficial. So I'm a big fan of adaptogens. A lot of these mushrooms are adaptogens. So like you see mushroom coffees, those are all full of adaptogens. There's all kinds of different ones. Ashwagandha is probably another one that you guys have heard of. So this is something you can look into as well. that you can drink in forms of tea or these little drinks, or you can take pills or whatever you want. So that's a real easy thing you can do. And then getting your sleep routine regulated. Sleep is really, really critical for proper immunity. Okay, so lymphatic support. So again, you want to be able to support the circulation of that lymph through the body so that you can help clear things out of the body. Deep breathing is a really excellent way to do this. And this is easy. Anyone can do it. It's free. You can do it sitting in your chair. So let's actually, since we're here, let's do it. Let's do a little deep breathing. So what I want you to do is I want you to breathe in for 1 count. And then I want you to hold that and count to 4 and then breathe out for 2 counts. Okay, so this, some people call this box breathing. All right, so let's all take a sec and we're going to do that. All right, ready? Okay, and you want to breathe in through the mouth, in through the nose and out through the mouth. And you can repeat this as many times as you need to. This has kept me from going off on more than one person in my lifetime. Okay. You can use this if your husband's getting on your nerves, or if your kids are driving you crazy, or if your boss has like pushed your last button or whatever, or even if just like you're in traffic and you're about to start screaming at something. This deep breathing is a really excellent technique. Again, it's very simple. It's very effective. Okay, so you may need to do this a few times, and that's okay until you feel better. A second way you can support your lymphatic system is to avoid personal care products that are toxic. So avoiding a lot of artificial fragrances, avoiding things with, like, for example, phthalates or parabens or any, number of things. That's a whole different discussion for a whole other day. Again, I have a whole program about this. So if this is something you guys are interested in, if you want to learn more about getting rid of certain types of personal care products and what to replace them with, that is a thing we can also do. So just let Connie know your interest, and we can definitely do that one as well. Regular massage is excellent for lymphatic circulation, and also things like dry brushing. All right, so there's this little device, it's called a dry brush, and you kind of like brush your skin. I guess that's the best way to describe it, and that helps to get that lymph circulating. Castor oil packs are also great. Hydration, we touched on this earlier because a lot of our lymph fluid is water. So water is what makes things move through the body. So that's no exception here. Regular exercise and anything else that makes you sweat. So like the sauna is also a great way to stimulate that. Rebounding, acupuncture, which is like where they put the little tiny needles in different parts of your body. And then a nutritious diet, of course. Of course, always that. All right, so what foods can help us keep inflammation down in our body? Fortunately, there are a lot of very common foods. Number one is healthy fats. So things like salmon and tuna, ground flaxseed, olive oil, avocados. All right, these are all very anti-inflammatory fats. Berries. So these are on my kind of daily list of foods that I make sure to eat. You can also do cherries. Pineapple is a great one as well, if it's not making you itchy like it does me, because it does have some histamine, so you'll have to test that one. Cruciferous vegetables, another big one that I are in kind of my top 5 for the day. So that can be broccoli, cabbage, Brussels sprouts, any of those guys. All right. Leafy green vegetables, another big one. Walnuts, almonds, and Brazil nuts. Brazil nuts are a great source of selenium, which is one of those immune supporting nutrients that we need. Fresh herbs are wonderful for inflammation. So I like to just chop them up in my salad. Like a lot of times I'll cut up some fresh parsley from my garden or some cilantro. I throw that in my salad. Ginger is a great one. You can cook with it. You can drink ginger tea. Garlic and onions, which pretty much stay in my repertoire. Most things that I cook, I'm going to be using one or if not both of those. So garlic and onions are also a good one to include. So just, something you can do kind of daily. So this is part of why eating mindfully is really important, like not just eating whatever we feel like eating. You know, that's a nice idea and it appeals to our hedonism, but it really pays to be a little more attentive and plan, you know, have some planning involved, because you can make sure that you're buying these things at the store. You can make sure you always have them on hand at home, and then you can figure out how to incorporate them into your day. But most of these, again, are pretty common foods and things that you likely would eat if you had access to them. So make sure you keep these on stock at home. Okay, so that was a lot of science, I know. I'm going to exit out of the PowerPoint so that I can see, because I saw a lot of comments coming through and questions. So I want to make sure that I get over to that. Yeah, Angie, that's a good point. Garlic and onions, for some people, are not very well digested. They are a high FODMAP food. So you guys might remember me talking about FODMAPs in the digestive discussion. So they can be high in FODMAP. So, you know, you could try doing it in like powder form and see if that helps. If not, then, you know, don't use those, obviously, because we don't want to eat foods that we're sensitive to, right? And then just, you know, use the other ones that you do tolerate. Okay, so I'm trying to get back to the big screen here so that I can. Let me stop sharing the PowerPoint first of all. That will help. Okay, here we go. All right, so let me scroll back up to the top because we got a lot of input here. Let's see. Okay, so the first question was when we were talking about the immune response, this is the body's way of ridding the pathogen. So when we take Tylenol or cough medicine, does it interrupt the healing process? Yes, actually, particularly things that are lowering the fever, because you need the fever. The fever, again, is the first part of that response. So you're supposed to actually allow yourself to run a fever up to a certain point. If you get to like 103, that's dangerous, okay? But if you hit 100, you're actually supposed to leave it alone and let it ride, and don't try to bring the fever down, because the fever is working to kill those pathogens. Cough medicine to an extent too, because coughing is part of the body's attempt to expel the thing from the body. So it really just makes you feel better, but it isn't helping. Yeah, so, and then some of these were things we talked about already, with like needing moisture, needing hydration so that you can keep your mucus and your lymph flowing. You can do self lymph massage as well. I guess dry brushing is what you mean, but you can chime in if you mean something else. Many root canals still create infection, and diseases have been linked back to them. Oh, that's interesting. I don't know as much about that. I have heard about like dental plaque and like being a risk factor for like heart disease and diabetes. I haven't heard that about root canals, so that's interesting. Yeah, MTHFR mutation, food sensitivities. Yeah, Jessica, you and me, girl, we're on the same boat there. I think half of Jessica and my conversations are about this kind of stuff. Like, we both found a wine we can both drink, and it's like a big deal, you know? Yeah, heavy metals can impact everything. Yeah, so again, if you have a lot of this stuff going on, if a lot of this stuff sounds familiar, another thing you could get tested is heavy metals. You could get your hair tested. Exercise helps deliver oxygen to our cells. Yes, definitely. Cancer cells liking acid. Well, yes and no, because certain parts of your body are supposed to be acidic, and yet we still get cancer in them, like the stomach, for example. So not necessarily. I mean, some of this has been perpetuated by people that advocate an alkaline diet, with kind of making people think that you can make your body alkaline, which you can't. That's literally impossible. And if you do, you're not in a good state. You're actually critically ill. So yes and no. So the word acid is kind of misleading in this sense, but Certainly anaerobic, you know, if there's not enough oxygen to a certain part of the body, then yes, it does make a more cancer-friendly environment for sure. Jess, that's interesting about the smoking, your dad and the smoking thing. But smoking actually, smoking has some interesting connotations. Like, for example, smoking actually tends to benefit people with Crohn's disease because the nicotine helps to relax the contractions of they get like these spasms in their colon, and the nicotine actually relaxes it. It's kind of interesting. So yeah, it's kind of interesting. But yeah, I mean, that's why a lot of people smoke, is because it helps relax them, and maybe could even lower cortisol in certain individuals. Jess, if you go back to the slide where we were talking about histamines, there's a list of the high histamine foods, but like sometimes like fermented food, sometimes citrus, pineapple, things like that. But yeah, go back to that slide. They're listed there. Lymphatic massage is different than dry brushing. Okay, I'm not sure exactly what that is. So maybe Connie can chime in on that to elaborate a little bit. So I don't know, other than like deep tissue massage, I know that's more conducive, but Connie, can you touch on that?
Well, the lymph resides just underneath the skin, so you don't need to have light touch. And you can go in a certain corner because the lymph dumps in a couple of places in the body, so you want to make sure that you have your exit. But you can divide it up to just doing like the head, so or you can use it, but some massage therapists do an actual lymphatic massage. A lot of people that are going through some treatments and whatnot, they'll use that as one of
You kind of broke up there at the end, but it sounds like it's Jessica's saying it's a very light touch, I guess.
Yeah.
Okay. Feels like nothing is happening, but it is. Okay. That makes sense.
Actually, if your ear is clogged up, you do this little massage, you'll notice that it gets better right away.
Okay, Janelle's got to jump off, but okay, thanks, Janelle. We'll see you next week. Okay, so I think I got everybody's questions, and I think I addressed all the comments that I hadn't already touched on. Y'all feel free to roll back and look at the input. Some people gave some, like Jessica gave some recommendations for like the mushroom coffees and things like that. So if you're interested in products, you can look at that as well. So, but since it's at 8:15, we're gonna let everybody go. Thank you guys so much for joining us, and we will see you back here next Wednesday, same time, for more fun science.
Thank you, Jean. Night, everybody.
Thank you. Have a great night, everybody.